Okay, so we're going to talk about what's called rationalizing the denominator. You need to get used to hearing that word. We'll talk about that a lot for the rest of the year. Again, what rationalizing involves is simply rewriting what we call a radical expression as an equivalent expression in which the denominator no longer contains any radicals. Okay, so somewhere along the way, somebody decided that they did not like radicals in the denominator. And so we always do what we call rationalizing so that there's no longer radicals. So an example, and this one I'm going to call it if the denominator has a square root of b in there. So what I mean by that is if I have something like 2 over the square root of 3. Okay, that's just a square root of b or a single radical in the denominator. And the method that we use is actually very easy on this, and it kind of goes back to problems that we did earlier. But if you take the square root of 3 and multiply it by itself, okay, and since I did the denominator, I also have to do the numerator, okay? The numerator is just going to give me 2 square root of 3, okay? But the square root of 3 times the square root of 3, guys, is the square root of 9, which is 3. So that's kind of going backwards in what we were doing earlier when we were prime factoring it down. Okay? So in fact, guys, here's a rule to put in your notes. In fact, if I take the square root of any number times itself, it will always give me that number. Always. Okay? So put that in your notes somewhere. You want to have that. Okay? Here's another example. If I have 3 over, let's say, the square root of 5, okay? Then I take the square root of 5, numerator and denominator, and I get 3 square root of 5 over 5. Okay? Pretty quick. Okay, so do these along with me. Okay? So again, 2 over the square root of 3. I would multiply top and bottom by the square root of 3. Always by whatever your denominator already is, because so you want these two to be the same thing. So I get 2 square root of 3 over 3. Now, it doesn't make any difference, like on number 2, where they're both square roots. It doesn't matter. I'm only going to go to the denominator because that's what's going to be my driving force. It's my denominator. So I'm going to multiply top and bottom by the square root of 5. So that would be the square root of 10, and the square root of 5 times 5 is 5. Now, do not try to divide that 5 into that square root of 10. Think of that square root symbol as being a grouping symbol. It is holding that 10 in there. You cannot break into that grouping symbol, okay, on there. That is as low as it'll go. Okay, here's 3 more. The first one I give you, number 3, is very easy, okay? Now, but what you're going to see different in these is the fact that they're all underneath the radical, not just one or the other. But here's what you can do, guys. You can just take the square root of 25 over the square root of 16. I can just break it apart, okay? In this case, the square root of 25 is 5. The square root of 16 is 4, okay? I'm going to do the same thing over here. Square root of 4 over the square root of 5. The square root of 4 is 2. Square root of 5 has to stay. But I have a square root in the denominator. So now I need to rationalize it to get my final answer. So 2 square root of 5 over 5. What do you think of that? Final one here. Again, I'm going to take this and I'm just going to break it apart. And then I'm going to rationalize. Again, don't try to break the 7 into the 21. You cannot do that. Okay? So we're going to try some of these.